I've been in the construction field some capacity or another for 25 years. I've recently, in the last 15 years, have been exposed to ICF, and the last 12 years been installing ICF. So saw an opportunity there, liked the product, and away we went. So that's how it all started. Some common myths of ICF. The main common myth of ICF is it's too expensive, I can't afford it. And the bottom line is you can't afford not to do it. If you compare foundation, poured wall foundation to an ICF foundation, it's dollar for dollar. It's the same product or same money with a much better finished product at the end. When you go above grade, you stop all the thermal bridging. You stop the cold penetration through the box sill, which is the floor band row of the house. So you stop all air penetration, or the majority of it. You still have your windows and you have your doors where the air comes through, but for the most part, you have created a very solid, very energy efficient envelope that's very safe, very quiet. ICFs is not difficult at all. It's a very light product. It's the first time or two that you work with it, you struggle maybe just a little bit, just like you do the first time or two you work with anything. But as you get onto it, and it's just a matter, they're 16 inches tall by 4 foot long panels or blocks, inside and outside ice or foam panel connected with ties, and you just stack them together. And then when the next row goes on, the corners are staggered. There's left and right, so you offset the corner, you put the opposite corner on, you did the row below, and then that offsets the joints, and it just stacks it up and makes it straight. Like I said, it's very light to work with. It's easy. It's once you've done one or two, it's pretty much as fast as a poured wall foundation. But when you're done, you're done. There's no energy wall needed inside. There's no other trades that need to come in to build anything to bring the product up to code. It's already there. There's every advantage to the ICF. It's even with the energy wall, even with most of the time they are foam spraying that insulation, because regular bad insulation typically will not get you up to the R value you want. And by the time you do all that, it is still not as good as an ICF foundation for several different reasons. One being moisture. The cold penetrates through the concrete wall, meets the warm, and what happens then? You get condensation. So you always have that problem with a poured wall foundation. No matter what you do on the inside, you're always going to have that problem. You do not have that problem with the ICF because you have the insulation on the outside and on the inside. So that takes that issue away. There's no food value to it, so rodents typically leave it alone. Insects typically leave it alone because there's no food value to it. It's much quieter than any other kind of foundation there is. Every 8 inches on center, which then equates to every 16 on center, just like regular framing, there are plastic ties that are molded into the ICF, or plastic webs. Then the ties go from the inside panel to the outside, so everything is connected from the outside to the inside. And it's an 1.5 inch wide plastic tab, and that's what you screw everything to. You can nail to it, you can screw to it. It's best to screw to it, but in some of the ones I've finished, I have nailed baseboard with a finish gun right to the wall, and the nails hold very well in the plastic. If you're just doing the foundation, the joist will set on top of the foundation wall on the treated plate. If you're going all the way up to the rafters with it, there's actually several different ways you can do that. You can actually use a brick ledge block, put the brick ledge to the inside and set your joists on that. You can use a hanger system that gets concreted into the wall when you pour it, and then it's a two-piece system. Then there's a J hanger that mounts to that. That's the method I prefer. Or you can go from an 8-inch wall to a 4-inch wall, and by 8 or 4 I mean the core. An 8-inch core wall is 13 inches thick with the foam. A 4-inch wall is 9 inches thick. So you can go from 8-inch to 4-inch, then you have ample concrete there to set your floor system on as well. Typically we pour in 4-foot lifts. You can, and I have done it, I shouldn't even say I've done it, but I've done it, that I have poured in one pour, 8 foot tall, all the way around the building. And it holds up. I wouldn't recommend it, but it will work. But you should pour in 4-foot lifts. And then you use the vibrator and consolidate the concrete. And what the vibrator does is consolidates the concrete around the ties, around the rebar. The concrete mix you use is very important to make that all work right. And you typically use a concrete pump, because you can't get a concrete truck close enough to a foundation just to tailgate it or pour off the truck. So it's very easy to pour. When you set the walls up, there's a bracing system. There's verticals that you fasten to the wall. Then there's, I call them A-frames, which mount onto the vertical, and then that's what holds your planking system to walk around and pour the wall. And then of course there's a turnbuckle so you can straighten the wall. And it's just a very easy process. Well, a lot of times a homeowner, do-it-yourselfer, even a contractor that hasn't worked with it before, they will stack it and not have the ties lined up. And then when you go to fasten sheetrock, or you go to fasten on anything to the wall, you don't know where these ties are because they'll be off a couple inches. So that is very important that you make sure the ties line up all the way from the bottom to the top, and that's very easy to do. But it's a must, because that's one thing that everybody really doesn't like, is when you can't find a fastening surface in the wall. It's every bit as straight as a framed wall, if not straighter, because wood is forever moving with the climate, and the concrete and the EPS foam, they don't change. So what you do, or what we do, is after you pour it, you pull a string line from corner to corner, and then you use your turnbuckles and you push or pull that wall until that whole wall is perfectly straight with that string line. And then it's good to go. So that has to be done while the concrete's wet. You get done pouring the wall and you straighten the wall. That's the next thing you do. And then you mag off the top of the wall and put your anchor bolts in, or your rebar, depending on the situation. If you're going up farther, you have to put vertical rebar in, to consolidate, or for the structure, for the strength of the wall going up. If that's as far as you're going, you mag the top off. You set your anchor bolts. You just do them per code. The code's relatively the same. It's I put them every 4 feet. Code, I'm pretty sure it says 6 feet, but I put a few extra in just for good measure. So. Residential is a lot different than commercial, but there is, in prescriptive methods, there is some different tables to tell you how much you should use depending on your backfill height, depending, like a 4-foot frost wall is going to have a balance load, which means it's filled on the inside and filled on the outside. Actually does not require rebar. We always put rebar in it anyway. We put verticals every 4 feet, put a horizontal at the bottom and a horizontal at the top of the wall, but it does not require any. And even an 8-foot ICF wall, if the backfill height is no higher than 6 foot, it does not require any either. But you always put it in. And typically what I do is I put horizontal bar in every row and then stagger them inside and out. And then I put, I usually have vertical rebar every 2 feet. Just because when you're done, you want a really good product. I do tie it down. In our ties, it's a saddle to hold it. So, I mean, it doesn't clip into it. So I always tie it down just to make darn sure it's not going to move. Just use a regular twist tie. You can either zip tie it with a plastic tie, or you can use a regular, I guess I don't even know what the heck the technical name is, the pre-loop tie wire, or a spool of tie wire. But I always do. It's just another course, or another, six courses is 8 foot, 7 courses is 9'4", and 8 courses is 10'8", because it's 16-inch increments. So there's really nothing different than you have to do when you do it. The nice thing about doing that is typically, the top of windows are at 6'11" off the floor. That's the top of what the window rough opening is. So if you go higher than 8 foot is preferable, because you get more concrete above the windows. Higher than 9 feet, it's no big deal. You just go on up. Well, strapping is very important. What I use, and everybody uses something different, but I use 1x4s, just number 2 1x4s. For 2 reasons: they're light, they're easy to handle. You can use 1 5/8 drywall screws, and you just, it's real fast. But you strap the corners, you fasten the strapping material, whatever you're using, to the ICF, and then that holds the corner block to the next block, because all your pressure when you're pouring, it's going to want to push that corner right out and away from the foundation. So you strap that so that won't happen, and just 1 strap on each row going each way is all you need. And I always screw into every tie. Some screw into every other tie. I just like to go into every tie. You're there anyway. It takes another 5 seconds to put 2 more screws in. And then common joints, and what a common joint is depending on the length of the wall, because we're in 4-foot increments, and depending on the dimension of the wall, you're going to have an odd cut. So you can do it 1 or 2 ways. You can bring that odd cut to the corner, because you're strapping it anyway, or you build from both corners, come to the center of the wall. That's where your common seam is, and then you strap that also. The foam is 2.5 inches thick. There's several different ways to do the wiring, but like at home, there is no conduit required in residential building. They use an electric chainsaw, which kind of makes a mess, but it's very fast. And they make their grooves to the wire and just tuck their Romex right into the groove, and they're done. They fasten the box right to the concrete, right through the back of the box. They just 1 tap con, it's in against the concrete, and it all works. But that's what all the people I've worked with like to use, because in a hot knife works. There's several different ways you can do it, The electric chainsaw is the fastest, but it's also the messiest, but little shop vac time, and that's taken care of. That's pretty easy to take care of. The plumbing, typically, there's not a lot of plumbing on an exterior wall anyway. If there is, it's coming up through the floor, and it's not coming up the exterior wall. Even in stick frame houses, they might have a drain pipe in an exterior wall, but they typically don't run water lines. They don't, any vent piping will be done through an interior wall, typically. So that's typically not an issue, is the plumbing part of it. And the electrical, like I said, that's that simple. Now when they do go horizontal with their wires, they have to go to block joint, because the plastic ties are a 1/4 inch down from the top of the block and a 1/4 inch up from the bottom of the block. So then you make that cut, and then your wire sticks right in there, and you're not cutting through plastic all the time. Heating and cooling, there's nothing in an exterior wall anyway. So it's no harder for ICF than it is for a stick frame home for the subs to come in and do. In fact, this summer I did one where we had several pipes coming up through the concrete wall. But typically, and it depends on the floor plan, because if it's a very, very open floor plan and you have, your great room that's 30 foot to the ceiling and you don't have a lot of interior walls, then you have to plan on that. But the trade, whichever it be, well, that'd be the plumber, obviously, and they'll get that all set and ready to go before you ever start. They'll put that all in, and you just pour around it, make sure you have your clearance between your pipe and your foam for concrete, and it's no big deal. But if it's done right, and if they do their research, you do not need as big of a heating unit in an ICF home, because you don't have the temperature variation, you don't have the air infiltration, you don't have any cold transfer whatsoever. So a smaller unit is required. Now, sometimes they will, I don't believe that, I'm going to put what I'd put in any house, and then they just don't run very often. They're on and off, and because if it's sized right, it should turn on and it should stay on quite a bit. So, but yes, there's, and I don't know the numbers. I don't know how much smaller it can be, but the heating and cooling contractor would need to do their homework and figure that out. There's several different ways to handle windows and doors. There's several different buck systems available. There's a Gorilla buck. There's some other plastic kind of bucks. And there's just a good old treated 2x lumber. I have always used the good old treated 2x lumber, is what I've always used. Done it several different ways, made 2 boxes with 2x4s. I've done it with solid 2x12s. If you're doing an 8-inch wall, then you have to add a 2-inch piece. So you end up with your 13-inch thickness. And you always have to put screws in the back side of it so the concrete fastens to it, so it doesn't move. The buck system, the Gorilla buck, basically does that same thing. It's cut for the opening. It's got tabs that go back so the concrete holds on to it. It's just a rigid foam that's got a plastic edge on the inside and out, and it's a more sealed opening between the concrete and the door opening itself, because it's EPS just like the other. And my experience is mainly in the residential. I've done some small commercial, but it's mainly in the residential. And it's just, if it's given a chance, it is no harder to do than any regular construction, and it's a much better finished product when you're done. It's common sense tells you a lot of the things you got to do when you're doing it, and through trial and error, that's the best teacher there is, because you really listen to yourself after you don't do it right. So, and it's just, and you know what, and even today, I'm still doing it, and you still learn something, a little something every time, that I think I'm going to do it that way from now on. So that's why I say once you get onto it, you can put an ICF foundation up in the same amount of time they can come in and do their pan forms and do a poured wall. It's within a day. So you just learn it. There's no wasted motion. Once you really get onto it, there's no wasted motion. So you know what you're going to do 3 steps from now while you're doing this step. So you just always know what you're doing. And that's the way it is in any trade. The more experience they get with it, the better they are with it. So, and this is no different. My advice would be to try to learn from someone that's doing it. Whether it's myself, and I've done a lot of times where I have gone and helped them get started and showed them all the tricks that we've learned over the years. I mean, the first thing I suggest is they contact me, and because this is Celblox is the best block to use. That's the first thing I would tell them. And just don't be afraid of it. It's we're all afraid of something new. A younger contractor getting into it's probably going to be less afraid, because as we get older, we get a little more timid about new stuff. So, but it's they'll never be sorry. And I've said it many times. I have built full ICF homes for people, and then they've turned around and sold them years later, and the only thing they would build is another ICF home. They will absolutely never be anything different. One of the reasons we had a power outage back home, I don't even know how many years ago. A couple that I built an ICF home for, they were out for 7 days, and this was in February, so it's 0 outside. And their house in 7 days dropped 2 degrees in temperature, was all because of the ICF. Where neighbors, everybody else, they're getting generators, they're running kerosene heaters, and they didn't have to do any of that. I mean, if they wanted electricity so they could watch TV or something, they needed a generator. But as far as for their house and comfort, it was all there. They didn't need to worry about it. We have seen some pictures of the thermal imaging between a stick framed home and an ICF home, and that tells the story right there. That just tells you how much cold transfer there is. You just try to convince them that this is the way to go. For one thing, it's a safety factor for the homeowner, because this product will withstand hurricanes, tornadoes. I mean, once it's full of concrete, obviously. Empty foam standing up doesn't withstand too much, but once the concrete's in there. And the concrete, one thing I always tell everybody, and this has been documented by the Ready-Mix Association, is after 1 year, an ICF concrete in an ICF wall has double the strength of the concrete in a poured wall. That's documented by the Ready-Mix Association. So, because it's a wet cure situation, it's just a superior way to build, and it does not. The upfront money is so minimally less, if any. But the perception is it's too expensive to build with, and I've been fighting that for the dozen years I've been doing it, and I've bid job to job and showed them and it's dollar for dollar, and it's still too expensive. It makes no sense, because it's different. So it's so much of it depends on the builder, on the homeowner, how open-minded they are, how closed-minded they are. If they're willing to listen, you can 9 times out of 10 you can convince a homeowner that ICF is the way to go once they get through all the bidding process. And then once they're done, their utility bills are considerably less than they are in a stick-framed home or in a poured wall foundation home. Well, and I think, and it's pretty easy to prove, just through through the bookkeeping part of it, but most builders hire the foundation done, so they're not getting any profit out of that foundation. Where if that builder is going to build with ICF, he can come in there, he can do it all himself, and he's getting all that profit from that foundation that concrete contractor would have had on his foundation. So you can actually make better profit on a job building with ICF than you can with a poured foundation and a stick frame main floor. What would cause that to be more profitable is when they're done above grade. Yes, you do not need the insulating contractor to come in. Pretty much everybody else, because the framer, the builder, is going to do the exterior walls and do the sheeting. None of them insulate anymore. They all have a company come in and do it, so obviously there's profit there with that company. So if they install the ICF by themselves, they're utilizing that profit. They're still making their same money as they would have made stick framing the main floor, but now they're actually getting the profit from the insulation company, because once you're up and it's poured, the insulation's done. You put a roof on, throw the windows in, and it is fully insulated, and it's ready for the subcontractors, the plumbers, the electricians, the heating and cooling guys.
How hard is that to do?
Typically, building with ICF, and every crew is different. Every contractor is different with their crew size. But you do not need any bigger crew to build with ICF than you would build with a stick framed house. In fact, probably can get by with less, but of course, your employees are there. You're going to put them to work. The more you have, the faster you put it up. But it's, and you're dealing with, and I don't even know what these block weigh. They can't weigh 5 pounds, I wouldn't think. You're just dealing with light, easy work the majority of the time. So, your average crew is probably 3 to 4 people on a crew, and that is plenty sufficient on an ICF project as well as on a stick framed house. Some crews are bigger, some are, some guys do it with 2 of them, and that works too. It's just however many you have, it works. It's another reason I liked it. Concrete work is hard enough the way it is. It's a gut wrenching hard job, but handling these block and putting them together, you're not exhausted at the end of the day like you are when you handle pan forms. And I have a set of pan forms too, and they never leave the shed, because this is just such a superior way. And with the dollar difference being so minimal, if any, to me it is the only way to build a house.